Well, hey there, Troll Pal, Mr. Cook. We just went through the first 6 problems. Let's say we go through let's go through the next 6 problems. Why not? So it says to state the quadrant in which the terminal side of each angle lies. So the terminal side, that's just going to be like, after you go through writing out the whole angle, okay? The terminal side is just like the side of the angle that you're left with, like where the arrow ends up pointing to, like where this arrow stops. Okay, so that's what we're going to try and do for this. Let's see what happens with 550 degrees. Okay, so I always like kind of draw it out because I'm a more visual person. And I would go like this. I'd go, okay, so 550 degrees. So I'd go 90, then another 90, that's 180, then 270, then 360. So one full circle. And then if I add on another 90 degrees to 360, that'd be 450, and then 540. Okay, so I'm at 540. That's already really close to 550. So I'd go another 10 degrees. So that wouldn't be enough to go another 90 degrees over to here. So that means that my terminal side just stops there, and it's in this quadrant. So you might have to remember where the quadrants are. In the upper right corner, that's quadrant 1. And then we go counterclockwise after that. So just like the angle goes. So it'd be quadrant 2, quadrant 3, and quadrant 4. Okay, so just like how the angle goes counterclockwise, we start at 1, 2, 3, 4, and then 1, and then 2, and then we end at 3. Okay, so that's the path of our angle, 550 degrees, and we go to quadrant 3. So Q3 is what I'd write there. There we go. What about negative 7 pi 6? Well, geez, I mean, again, it's that stupid radians. I'm just going to convert that to degrees, okay? Hope you don't mind. X over 180 is equal to, then it's negative 7 over 6 pi over pi. Well, the pi's cancel out. They're gone. So I just got X over 180 equals negative 7 over 6. Then I'd use my calculator. I'd multiply 180 onto both sides. So X equals negative 76 times 180. Let's see what we end up with, okay? So negative 7 over 6, and then times 180, I get negative 210. Okay, cool. So this is really just a negative 210 degree angle. So let's see what happens with that. Okay, negative 210 degrees. Excuse me. Okay, so if I have a negative degree measurement, that means that instead of going counterclockwise like this, it means that I start at 0 and I go the opposite direction. So I go clockwise. So I just follow the path of an analog clock. So starting at 0, I'd go this way. So I go 90 degrees. Another 90 puts me at 180. And then if I go another 90 degrees, that puts me at 270 degrees, negative 270. But so that's not going to be enough for me. So I just end up right over here. That's going to be my negative 210 degree angle, like all the way from here all the way over to there, okay? And where does that leave me? Oh, gosh, I forgot all the stupid quadrant stuff. Let's see, quadrant 1, 2. Okay, so it's in quadrant number 2. So I just write Q2 right next to it, and that's my answer. Okay, so that's the other quadrant one. Okay, find a positive and a negative coterminal angle for each of the given angles. Boy, these are so easy. Coterminal angles are like the simplest thing in the world. It just means that the terminal side, it just repeats itself. The only way that you can do that is if you add or subtract 360 degrees for angles, or equivalently 2 pi in terms of radians, okay? And all you got to do is just get a positive and a negative coterminal angle. This is so easy. So watch this, all right? Let's get another positive coterminal angle from 690 degrees. So if I'd start with 690, I could add on 360 degrees, and that would give me another coterminal angle. So if I just add those up, let's see, that's a 0, a 5, and then a 10. So 1050. So there's one of my positive coterminal angles, 1050 degrees. It's that easy. Just add on 360 until you get another positive angle measurement. Let's do the same thing over here. I'm just going to take negative 60 degrees and add on 360 degrees. Okay, well, if I do that, then I get 300 degrees. So that means that 300 degrees is a positive coterminal angle for that thing. And I can keep adding on 360, by the way, if I wanted to. That would give me more and more and more positive coterminal angles. So like if I added on another 360, another positive coterminal angle would be 660 degrees. And if I added on another 360 degrees, that would be, 1020 degrees. I can just keep going and going and going forever and ever and ever, okay? Those are all positive coterminal angles. Now let's find some negative coterminal angles. So the way that I do that is by, instead of adding 360, I subtract it. So I'm going to take 690 and I'm going to subtract away 360 degrees. So if I did that, I would get the following and get 330 degrees. Now here's an important thing. I need a negative coterminal angle. Is this a negative angle that I end up with? Of course not, right? 330 degrees is positive, okay? So it's not quite a negative coterminal angle yet. So what I do is I subtract 360 again until it's a negative angle. So 330 minus 360, if I use my calculator for that, I get a negative 30 degrees. There's one of my coterminal angles that are negative now, negative 30 degrees. So there you go. There's one positive coterminal angle and one negative coterminal angle for this angle, 690 degrees. So now I do the exact same thing here. I've got negative 60 to start, and I'll subtract another 360 degrees. If I do that, I end up with negative 420 degrees. And since that's negative, I'm just going to leave it. That's my negative coterminal angle. So negative 420 degrees. And if I wanted to, I could keep going and get more and more and more negative coterminal angles, like negative 780 if I subtract another 360, and so on. I can just keep going and going and going forever. There's infinitely many positive and negative coterminal angles for any individual angle that you start off with. And so that's also true for radians. So again, if you hate using radians, just convert it to a degree, but then you've got to convert it back to radians at the very end, okay? I don't really have a problem with using radians, so I hope you don't mind. I'm just going to do the radian approach for it. I mean, like I did it first, right? But I learned to deal with the radians. I learned to see them as just like another way to measure an angle. So I still see them as like fractions of pi. Pi is 180 degrees equivalently. So that's how I always look at it. So all I have to do, very similarly, is just keep adding or subtracting 2 pi. And I'll even show you like a secret on your calculator to be able to add those values on really easily and just use your calculator's fraction option to get an equivalent fraction. So check it out, okay? I'm going to take negative 5 pi over 4, and I'm going to add on 2 pi. Now, if you did that with your calculator, you'd mess up. You'd end up with this like really messy value. Watch this, okay? So if I use the calculator, negative 5 over 4 times pi, and then plus 2 pi. Oh my God, that's terrible. And if I try to use the math fraction, it doesn't do anything for me. Oh, that sucks. So here is like the easy thing that you can do, okay? Check this out. All you got to do is just like factor out the pi because they both have pi's on them. So if I factor out the pi, I can just figure out what the fraction is. I just do negative 5/4 plus 2. You do this on your calculator. That'll give you the fraction of pi that gives you the answer, okay? So check it out. Watch this. Now if I just concentrate on the negative 5 over 4 and add on 2, oh, that's a lot easier. I even know what that is. That's 3/4. Watch. If I hit math and then fraction, 3/4. So this is really just 3/4 of a pi. So if I add those two things together, I get 3/4 of a pi. So here's like the trick for you. Are you ready? Just add or subtract the numbers and then slap a pi on at the end, okay? So that gives us our first positive coterminal angle, 3 over 4 pi. There we go. Now let's find a negative coterminal angle. So I'm going to subtract away 2 pi. And let's use the exact same logic as before. If I factor out the pi, then I really just have to worry about the fractions, negative 5/4 and a negative 2. Let's see what we get in our calculator if we do that. So negative 5 over 4 minus 2, that gives me negative 3.25, math, fraction, negative 13/4. So this fraction just turns into a negative 13/4, and then I slap on a pi at the end. There's my negative coterminal angle. It's that easy, guys. Can you believe it? So simple. All right, let's do the same thing over here. We've got 2 pi over 3. So I would, add on 2 pi. So 2 pi over 3 plus 2 pi. So of course I would do the exact same trick. I'd just concentrate on the numbers, 2/3 and 2, and then figure out what that's going to be with a pi on it. Okay, so let's see here. 2/3 plus 2. There we go. Turn it into a fraction. And we get 8/3. Okay, so this thing, one of the positive coterminal angles is going to be 8/3 of a pi. Now let's subtract. So we've got 2 pi over 3 minus 2 pi. So again, we're just going to take the pi part out of it and do the 2/3 minus 2. Figure out what that fraction is, and that's going to be probably our negative coterminal angle. And if it isn't, we don't have a negative coterminal angle yet. We just keep adding 2 pi or subtracting 2 pi, whatever we need to get. It either be positive or negative. Okay, so let's see, 2/3 minus 2. And then change that to a fraction. Look at that, negative 4/3. Okay, so a negative coterminal angle is negative 4/3 pi. There we go. All right, so we have a positive and a negative coterminal angle. There we go. That is the next 6 problems. This one took a little bit longer than I thought. So let's go through the next ones on the next video. Let's do, oh my gosh, look at all those. Find the exact value of each trig function. Well, that's all unit circle stuff. We can do that pretty quick. Yeah, we'll do number 13 through number 26 just all at once on the next video. All right, thank you very much. I'll see you in the next one. Bye-bye.